Hi, and welcome to this series of videos presented to you by iGEM Athens 2023. Throughout our journey in the iGEM competition, and as our project was making progress, we once had to face a problem that required combinatorics as a knowledge background. Thus, our team decided to create this series of videos as an introductory step in combinatorial analysis. Through these videos, you will get familiar with every basic combinatorial tool, and you will be able to use them in order to solve basic problems in combinatorics. It should be noted that no prior knowledge of mathematics is required to watch these videos, and as a result, we will begin with very basic but important stuff. But before we start, allow me to explain what combinatorics exactly is and why I deem it a useful subject to learn. So, combinatorics is the art of counting sets as well as studying the properties of finite structures. It is a very strategical field in mathematics that answers questions for the structures that we study. For example, given a certain amount of criteria, can these structures even exist? If so, in how many possible ways can they exist? And even if these questions are answered, another one comes up in mind, and that is whether there exists a structure that solves our problem in the most efficient way. So why would someone want to learn combinatorics? Well, apart from the fact that this subject improves our general problem-solving technique and makes us more mathematically mature, combinatorics has lots of applications in many fields outside pure mathematics, such as computer science, evolutionary biology, statistical physics, etc. Another important fact is that combinatorics allows us to make calculations that would otherwise seem pretty impossible. This can be done thanks to certain formulas that can be applied for any finite set of objects. And last but not least, it's a playful subject. In fact, every combinatorial problem seems more of a puzzle than a strict mathematical problem. So, having all that in mind, we may begin by stating the multiplication principle. The main idea is that if one event can occur in n ways and a second event can occur in k ways independently of the first, then both events can occur in exactly n multiplied by k ways. Notice that the word independently is essential here because the principle is not necessarily valid in situations where the second event is dependent on or restricted by the first. Here are a few examples in order to make sure that we understand the multiplication principle. So the first question is how many tetrapeptides are there? Note that in all of our examples we will be using the 20 amino acids of the standard genetic code. So in a tetrapeptide we have 4 positions. Each of those positions can be filled with 20 different amino acids. So in total, according to the multiplication principle, we have 20 multiplied by 20 multiplied by 20 multiplied by 20, or 20 to the 4th power possible tetrapeptides in total. Okay, so here's another example. This time, the question is, how many tetrapeptides are there that have methionine as their last amino acid? Okay, in this case, each of the first 3 amino acid positions can be filled with 20 ways, just like before. And the last position is fixed. So according to the multiplication principle, we have 20 multiplied by 20 multiplied by 20 multiplied by 1, which corresponds to methionine, or 20 to the 3rd power possible tetrapeptides that satisfy our condition. Notice that this number is equal to all the possible tripeptides, and this should not come into surprise, as in our example the 4th position was fixed. You may consider it as a constant. We proceed with a more difficult example. So we have, let's say, methionine, arginine, cysteine, alanine, and leucine. Okay, and we ask ourselves, in how many different orders can these 5 amino acids be placed in a pentapeptide so that no amino acid is being repeated? So no repetitions are allowed. We have 5 positions of amino acids in a pentapeptide. Consider the first position. This position can be filled with 5 different ways. We can choose any of the 5 amino acids that we have in our hands. Now for the second position, there are 4 choices of amino acids, as we have already used one in the first position. For example, if we have filled the first position with methionine, then we can fill the second position with arginine, cysteine, alanine, or leucine. So 4 choices in total. With this mindset, the third position can be filled by 3 possible amino acids, the second by 2, and the last position can be filled with the only amino acid that is left. In total, due to the multiplication principle, we have 5 multiplied by 4, multiplied by 3, multiplied by 2, multiplied by 1, total pentapeptides that satisfy our condition. So to finish this video, we will just make the previous example a little bit more difficult. We still want to find the total amount of pentapeptides that can be constructed by amino acids without repetitions, but this time we have 10 possible amino acids in our hands. The strategy is exactly the same. The first of the 5 positions can be filled with 10 different ways. The second position can be filled with 9 possible ways, as we have already used one amino acid in the first position. It doesn't matter which amino acid that is, the only thing that matters is that it cannot be repeated. So filling all the 5 positions, we deduce that the total amount of pentapeptides that satisfy our condition is 10 multiplied by 9, multiplied by 8, multiplied by 7, multiplied by 6. Well, at this point, you may be wondering, isn't there a shortcut to write all those multiplications in a more elegant way? Well, there actually is, and we will be talking about that in the next video. For now, I really hope that you enjoyed this introduction and feel free to ask any questions in the comment section below. Have a good day.